few news articles. Apparently, it's now going to be legal to fly drones over people. I know the rules have been unclear about drones for quite a while, making it unclear what you can do with them legally. And so there's a lot of companies that are helping people do things like check their fences with drones by breaking the law. But we're slowly developing whatever the licensing and safety requirements are. So maybe that'll make it easier. Hyperledger is the most important blockchain program. It's the one I'm going to focus on mostly next semester in the cryptography course. It might be worth just skipping ahead to this, which is an important fact. The same as I've been saying all along, everybody, all financial professionals and all coding professionals hate blockchain. And this is the developers. Blockchain is garbage. It doesn't solve anything. All a blockchain is an incredibly expensive and complicated way to make a mirror image of a database. We already have databases with mirror images. But anyway, it's a thing to know. It has become a fashionable way to steal money from people to the extent to where it's going to be a huge part of our economy. And there's a lot of things in the economy that I don't like prostitution and heroin, that become popular enough to where you just can't do anything about them. So they become part of the economy. So we'll cover them in the cryptography class and how to set them up. But in fact, this is just madness that will burn out after a while. Is it legal to shoot down a drone? That's another good question. And I don't know the answer. I know some people have done it. Some people shoot down police drones and stuff. And as far as I know, that's one of the many reasons why it's not entirely clear whether you can use drones to deliver packages flying over people's houses and stuff. That's why this is an attempt to start passing laws. Right now, it's very unclear. No way my professor is streaming. Oh, well, I don't know. Anyway, all right, anyway, so Hyperledger Cactus. If you actually were to use blockchain for some business purpose, IBM has the best one, Hyperledger. They've got a whole Active Directory infrastructure of a dozen blockchain products to run on every device because somebody at IBM believes that this is going to be useful, and they've really made enterprise-class blockchains. So now they've even made Hyperledger Cactus, which is sort of the interoperability blockchain product. So anyway, that's assuming blockchains not only work and become common, but multiple versions of them become common. So this will now talk to many different blockchains. And doesn't it vary in jurisdiction? I would think it would, yes. I don't know the details, but I would think right now all the laws, like if someone flies a drone up and shines a camera in your window and takes pictures of you, have they committed a crime? If so, what crime? If you shoot them down, have you committed a crime? I've seen cases like this go by, and I think there's nothing resembling a real clear standard at all. None of this stuff ever becomes clear until you actually have some cases resolved. So Apple has had an interesting leak. They did not hack Apple. They hacked Quanta, which is a company that supplies MacBooks. But what they stole from Quanta was the design documents for upcoming Apple releases, which Apple treats as extremely confidential. Remember, Steve Jobs sued a bunch of his own developers for leaking out copies. Then one of the testers forgot a new prototype iPhone in a bar, and they moved heaven and earth to get it back. They're very, very, very concerned that nobody should see any upcoming Apple product until they are ready to present it in their approved way. So these guys are trying to demand ransom, and as they don't get the ransom, they are dumping out the schematics of Apple products, which are confidential and actually never released. And apparently the first one dumped out was in fact accurate. So that's kind of interesting. And it'll affect this class too. As I mentioned, I've had to give up on the project, so I was trying to get ready for today because Apple has changed their stuff again. It's very hard to hack Apples. They keep changing everything and you don't know, so all your tools quit working. Yeah, I remember that. That was the dumbest thing. Well, this is what people said. This is part of the magic of Apple. Steve Jobs would present the new products personally with every word carefully chosen, and it had to do with creating this incredible enthusiasm around Apple products. So he was considered a marketing genius, but one of the rules was you couldn't leak anything about it. He wanted to be the one that presented it his way to make everybody love it properly. So San Bruno, a few years back, had a gas main explode and just blow up some houses and kill a bunch of people. And apparently, if you've been in San Francisco for a while, you probably won't be surprised to realize that our pipes are even worse. What happened is they put the gas pipes are supposed to stay only above ground, so they can't get, but then something changed, and there are now quite a lot of them below ground. And if they're below ground, you have to connect them loosely to a house because of earthquakes. But what people do is they apply for permits to lay concrete foundations and encase the gas mains in concrete. And some inspectors will allow this, and some will not allow this, but both of them take months to make up their mind. So what people typically do is just dump them in concrete anyway. And then they rust out, and then they leak, and then if an earthquake comes, they'll crack. And so according to this, the gas infrastructure under San Francisco streets is extremely messed up and fragile and likely to leak a lot of gas and blow up. So that's something to cheer you up if you don't find other things to worry about. And very, very believable. The more you know about San Francisco City and public works and stuff, the more believable this is. So here's another blockchain hack. So the NFTs are the non-fungible tokens, and the idea is that they represent ownership of some artwork. But in fact, all they do is give you a pointer to a URL that goes to a website, and they rely on an Ethereum smart contract. And if you've taken our hacking classes, there's an example there of $1 million hack of an Ethereum smart contract. The smart contracts are written in this JavaScript-like language, and the coding is generally pretty sloppy. So this guy found a vulnerability in the smart contract that lets him move tokens from somebody else's account into his account without actually having their permission, which is the sort of thing that tends to happen. At least he says he has. And he says he transmitted this $69 Beeple to another account. So we'll probably be hearing more about this. Maybe this is a real problem. Maybe it's some kind of fake or exaggeration. But it certainly is the case that nothing about blockchains, and especially nothing about smart contracts, is in any way refined and polished enough to trust this kind of money to it. None of this stuff reaches beyond what you'd call an early alpha version of any other product. I remember when Lisk was supposed to be the number 3 blockchain in the world, and when they announced their sales, I was there a couple of days before, and I said, well, I'll download it and run it, and the download links didn't work, the documentation links didn't work. There was nothing there but an empty box with a shiny label, because all it is a scam. That's all almost any of them are. They're just a thrown together prototype with the intention of running for a few months to get a bunch of people to buy it. Then it'll crash and you'll say, gee, I don't know what happened, and go on and do it again. If there's any actual product on the blockchain that's worth anything, let me know. As far as I know, they are all scams. Anyway, so I don't recommend investing in them, but you could become the programmer, helping to program them, and you could even begin fixing their flaws. And after another decade of development, they might get up to the level of a simple centralized database, which we've had for decades, because they don't add anything new except a lot of mind-boggling complexity, which will help confuse people. Anyway, so we're at Hacking Mobile Devices, and we're starting iOS. And I hoped to include a lot more iOS in this class, but I'm beginning to despair of it, because I found that a lot of the projects that get you inside iOS don't work anymore, which keeps on happening because Apple is very hostile to iPhone hackers. And every time iPhone get a good hacker, Apple updates everything and all the tools quit working. So anyway, but we can at least talk about it on a theoretical level. So let's start with that. And you will see that the internals of iOS are very much like the internals of Android. And iOS is really extremely secure in many ways. So we'll talk about the iOS security model and how apps and jailbreaking work, and then more things to go next time. So remember, the security model of Android is that every app installs as a different user on a multi-user system and runs with a different user identity, which is a kind of strange thing to do, and Apple does not work that way. Indeed, the early Apples just ran everything as root all the time, and there was no App Store, and there was nothing on there except what Apple put on there. But when they brought in the App Store, now you have non-Apple people adding apps, and those might introduce security problems. So here's some of the security features in iOS. They have an extremely secure boot chain. You cannot boot an iPhone to some other operating system. They have enormous efforts to prevent you from doing that. That became the industry standard, and this means you can't put a rootkit on it that messes with the operating system. And this is why Microsoft imitated it with their secure boot in their ARM-based Windows 8 tablets. And everyone has seen the iPhone as the model. iPhone is essentially a perfect security environment. It is possible to get malware and hacks on an iPhone, but it is very, very rare. So a normal user can just use an iPhone and not even worry about security at all, which is quite an accomplishment. So all the code is signed. They sandbox apps from each other. They encrypt all the data at rest. When you turn off an iPhone, all that data is encrypted and nobody can get it. They have the key stored in a special module, so you can't steal it with any malware or any app. And it's got all the mitigations of a modern operating system, like randomization of the address space, non-executable memory, and stack smashing protection, which is cookies on the stack. If you're taking our exploit development class, you're playing with these quite a bit, or the malware analysis. These are the things that make it pretty hard to exploit the common vulnerabilities in C, the memory corruption vulnerabilities. So, Apple, the modern iPhone, is a security miracle. It really has a very good setup. And so when you boot up the iOS, it starts with the boot ROM, and then it cryptically verifies the next stage of booting, and that cryptographically verifies the next stage, and that loads the kernel, and every bit of this has to be 100% accurate and verified cryptographically, or it won't accept it, to prevent you from tampering with anything about the OS. And this is the point is, if you have iPhone hardware, Apple wants you to run absolutely nothing except genuine Apple software on that device. Everything you run on it has to be signed by Apple, and that turns out to be a very good way to create security. It also means, of course, you can't easily add your own programs to it, which is why I'm having so much trouble hacking it. But that's the point. So it starts with the boot ROM. This is a read-only system, and it contains a public key for Apple's certificate authority. So it connects to Apple, and is used to verify the next step. And that's the low-level bootloader, which finds this iBoot module and verifies that it has not been modified. If it has failed, then it boots into recovery mode, so you can reinstall this stuff from Apple trusted sources. And then this is going to load the iOS kernel, and that's going to create the user mode environment and the operating system where you can see things like the App Store and stuff like that. So every stage has a cryptographic verification, and this works with a coprocessor. The same thing is called a Trusted Platform Module on PCs to exactly match the Orange Book Department of Defense specification. And on iPhones, they called it a secure enclave. And this is a special coprocessor to hold keys and perform encryption and decryption without having any of that process under the control of the main processor, so that no app running on the processor can ever steal the key or tamper with the encryption routine. That's the point here. So this is got key management for the data protection API and for the Touch ID fingerprint data. So none of that stuff could be stolen by a rogue app, even if it got root permissions on the phone. So this is a version of ARM's Trust Zone. There are many versions of this hardware secure processors, partitioned from the main processor. So even if you have kernel mode exploits and complete control of the machine at the very basic level, the ability to execute every instruction on the processor, none of those instructions will let you get at the data stored in this device. It's like an air gap. So that's the point. And those are very good. They're not absolutely impossible to defeat. There was a group, including some people from Stanford and such a few years ago, that actually managed to steal the data out of a trusted platform module on a Windows motherboard, but they had to destroy 100 of them to do it. They had to dissolve the thing with acid and reach in with a tiny little probe and try to find a pin where they could measure the voltage on the pin to get the key out. So, if you're willing to do that kind of heroic stuff, you can get in, but you totally can't get in by just putting malware on the device. It's much more complicated than that. All right, so then there's another one called Cachegrab, which was an attack against this because the secure enclave shares some cache memory with kernel processes, and so they were able to deduce some information out of there. And this is like the Spectre and Meltdown vulnerabilities that have to do with speculative execution. There's a whole class of these exploits that have been coming out over the last several years. The speed up features of modern processors tend to decrease the security by causing some process, some memory or something to be shared between a high security and a low security process. And that creates some degree of leakage, but in practice, it doesn't seem to be too bad. It's also almost impossible to fix. The only thing that would fix it is a hardware upgrade. All right, so the codes are signed. Every time you execute an app, it verifies the signature, and only code signed with a trusted signature can run. Now, you remember we did all these Android apps, and we could take a commercial Android app like the Progressive Insurance app. We could unpack it, modify it, repack it, re-sign it with our own self-signed app, and a phone that hadn't had the previous version installed would accept the new version. Because Android apps are just signed by self-signed signatures, which is kind of nuts. Apple does not do that. Everything has to be signed by Apple. You can't write an app and just put it on your phone, or unless you sideload it, and there are serious limitations on how long you can do that, how long the app will be there. Those are just for testing. If you want to get it in the App Store where anybody much is ever going to use it, you got to give it to Apple and pay for a developer account and wait for Apple to verify it and sign it with an Apple certificate. So everything you're running is either code Apple wrote or code Apple tested and signed. And it cannot have been modified after that point or the certificate wouldn't be verified. So that's the security model. It's really protected not so much by technical security, but by administrative security. You have to get Apple's permission to put anything in the store. And of course, they're not perfect, and there's always a few articles about people who manage to sneak some bad stuff in the store, but the problem is, if you do that, when Apple does find out, they will ban you from the store forever, and you'll never be able to make any more money selling apps. And that punishment is so severe that it greatly decreases the number of people putting poison in the store. So that's the point, the App Store. Apple won't let you do risky activities. They won't let you do self-modifying apps. They won't let you compete with Apple. They won't let you run anything that Apple just disapproves of for any reason. They will do things like let your app in the store long enough for them to make a copy of it, then kick you out and run their copy. Everybody complains about them hideously abusing their control of the App Store. They will demand 30% of all the money you make in the App Store. They will block you if you put any purchase function in your app that does not go through Apple, so they get their 30% and so on. That happened to Kindle. They had a way to buy another book in the Kindle app, and they had to take it out and make it go through the App Store so they could get their 30%. So, people get very, very upset about how abusive Apple is, but the fact is they have the only game in town. If you can't get in the Apple App Store, you have to try to sell your apps on Android, and Android users are not accustomed to paying any money for apps at all. You can't even get them to pay 99 cents for an Android app, whereas iPhone people are accustomed to paying 10, 20, 30 bucks for an app. So you can make a lot more money, so it's worth putting up with enormous abuse from Apple to get in the iPhone App Store for most developers. So there's process-level sandboxing. The apps run and are isolated from each other. They all run with the same user account. They're contained in their own directory, and there is a sandbox kernel extension called XNU that keeps the apps from intruding on each other's processes. And by the way, the same thing is true of Linux or Windows or the Mac. When you run multiple processes, they each have their own memory segment that's not reachable by other apps, even though they're all running with the same user account. All right, so in the Mac OS introduced this thing as Seatbelt in 10.5, then the app Sandbox, which was better. And then in iOS, it's now mandatory for all third-party applications. It's considered quite strong. Almost all the security features on an iPhone are considered very strong. It is really difficult to hack into an iPhone or jailbreak an iPhone. A good jailbreak or a good hack is worth more than $1 million on the open market, because that's what everybody wants, because all the rich people are putting all their secrets on iPhone and trusting them for good reason. So the exploits that work are extremely valuable to military and criminal organizations. All right, so when you install an app, any modern version of iOS, will ask the user if it's okay to give them things like access to your address book, just like Android does. And all the data is encrypted with AES automatically. It's turned on by default. So the file system key is generated when you first boot it up and stored in the flash storage. And when you do remote wipe, or when you go in the settings and reset your Apple to factory default, it erases that key. This in practice has turned out to be extremely effective. A forensic company bought 100 used iPhones on eBay and tried to find the old data in them, and they could not find any useful data in any of them, which is emphatically not true for Windows machines or Android phones or almost any other device you can have, like flash drives. If you find used ones, there's all this private data on them. But if you just go to reset it to factory default, that data is gone. No, there's anybody's ever going to get it back. That's the whole point of AES. If you don't have the key, just forget it. All right, you can encrypt individual files or keychain items with a key that's derived from the passcode. And that means when the device is locked, they're inaccessible. And that means even if somebody steals your phone and jailbreaks it and gets into the operating system, they can see the system files, but they still can't see your personal data, like your messages and whatever else you have in the apps. That's still locked behind your login PIN, which they don't have, presumably. All right. And it has the standard binary exploit mitigations. Write or execute is the fundamental rule of all modern operating systems. When you allocate a region of memory to be used by a program, it should be used either for writing or for executing, but never both. This means when the user puts in data, it goes in the writable area, and even if there's some form of memory corruption, they can't ever execute anything they put there. That's the idea. So you cannot inject code and then run it. And it also means the app developer cannot write self-modifying code. The executable stuff cannot be writable. Therefore, if you want to audit the code, you can audit the code, and it's not going to change in a different code when it runs. And as we mentioned a few slides ago, Apple won't let you put anything in the store that would load dynamic code from some third party, because of course then they wouldn't really be able to audit it and decide what it does. It might approve it and have people install it, and then it'll change to something else, and they don't want that to happen. So that's why this is the modern standard everywhere. No memory region should be allowed to write and execute, one or the other. All right. The only exception to this I've found is the Raspberry Pi Model 3 allows writable and executable regions of memory, which is a pretty serious error there, and I think they fixed it in later versions. So you can still bypass non-executable memory. If you can inject data into something like a string you can overflow, but not executable code, what you can inject is a bunch of addresses, which are then used to run code that's in the executable section, and that's called return-oriented programming, and we're doing it in the exploit development class. And so you have a series of addresses that are just read in the stack, and you can run code. This is like cutting up a newspaper to pick words out of it and build a ransom note. It's using code that was already there to patch together the pieces to build your exploit. Address space layout randomization just means that every time you launch a new process, it randomizes its location in memory. And that means that if an attacker is trying to run code, they can't find it. For example, if they're trying to do that return-oriented programming, they're trying to find a few machine language instructions followed by a return, but they don't know where it is because the processes are randomized in memory. If all the processes are always randomized in memory, then it becomes almost impossible to do return-oriented programming. All the return-oriented programming exploits I've ever dealt with rely upon finding some part of the code that does not move. And all modern operating systems that I've seen don't really randomize everything. And I don't know if the iPhone does. It's kind of hard to mess with the iPhone enough to find out. Anyway. So that's the weakness. And like I say, before iOS 5, the linker was not relocated, so you could find out where things were. Apps compiled with position-independent execution can use full ASLR. You have to compile them so that it includes enough information to let them be randomized. They don't have to load in just one spot. And all right, some apps do sit in a fixed location. So if you're running old apps on your phone, those apps might not have ASLR running on them. And I imagine some portions of the operating system are probably not randomized. I know that's true of Windows. All right, now the stack smashing detects if you've been overflowing buffers on the stack, which is the classic Stack Overflow exploit. You'll have a string variable for something like a password that's 10 or 15 characters long, and then you put in 1,000 characters. It runs off the end and it hits the control regions of the stack that include addresses, and then you can use that to control execution. But the cure for that has been known for a long time, 20 years or so, is you have stack canaries in the operating system. So after all the data storage and before the metadata, like the return address, it puts a random number called a canary. And when you're done running a routine and returning, it checks to make sure that the canary has not changed. And if it has changed, then it knows that a memory corruption has happened while running that routine, and it will stop instead of returning. So that's called stack smashing protection, and it's implemented with these random numbers called stack canaries, and Apple has it in the iPhone, just like every other mitigation that's expected. So there's three kinds of apps. There are native apps, compiled C++ or some version of C code, which is the most common. Then, of course, there are browser-based apps that are really just web apps running in a web browser, and then hybrid apps. So the standard apps, almost every app you get from the App Store and run, is written in Objective-C or Swift, various languages. Swift is the newer language. Then you compile it down to native code. So it is as hard to reverse engineer as a compiled Windows app, as extremely different than Android apps, which are compiled to Java bytecode, which is almost the same thing as Java source code. These compiled apps are compiled all the way down to binary executable code, much harder to reverse engineer. All right. And of course, the browser apps are just web apps that run in mobile Safari. So you just go to a web page and then you run them in there, and you use the usual stuff, HTML, JavaScript, and CSS, but not Flash. Even back in the days when other people were using Flash, you didn't get to use Flash on your iPhone. And therefore, you just secure them like a web app, and they really can't get to the operating system of the phone unless there's a bug in the browser, which has happened a few times, but Apple vigorously patches those because they don't like that. All right, and then there's hybrid apps that have a native wrapper and then have a browser-based app. So there's one way to do it. And there's a mobile enterprise app platform. You can, if you are a large enterprise, you can get permission to write your own apps that are not distributed through the App Store, that go only to phones within your company, that install a certain profile to allow that. So you can do sort of what you might do on Windows, where you'd have a domain controller which can push out software to the company devices. You can do that to some extent on Apple devices, but it requires convincing Apple that you're really a serious company. All right, so the App Store, you need to get an Apple developer account. If you sign up, then you sign up with a developer certificate. You can run it on testing for up to 100 devices, but you cannot put it in the real App Store where everybody can see it until it goes through a series of tests at Apple, and then they approve it. All right, and this is the thing I was talking about. If you want to develop custom apps inside your company that are not going to be available to the general world, you can you have to have a legitimate business and a Dun & Bradstreet number, which is something like proof that you're on the stock exchange or something. I'm not quite sure what it is. I had to go through a lot of hoops to get my code signing certificate, and this is even more extreme. You have to pass a sort of test to make sure you're really a known, reputable company. And then you can run on any number of devices, and Apple will screen the developers. So then you can have your own custom apps that are not in the store that will run on your company devices. So if those certificates get out, for example, this happened to make one of the jailbreaks. An expired enterprise certificate got out, and then if you change the date to the past, you could use it, and so then they were able to make a jailbreak. This is how the Panda jailbreak worked. Been through this before, making an LLC. No, it is indeed not easy. In fact, I was going to make an LLC when I made my startup, but my partner Richard said, no, I'll make you a corporation, and he contacted lawyers and did that. It became a real INC. Apparently that's easier than making an LLC, which is news to me. Thank God I didn't have to do it. My partner did it, because I'm not good at that kind of stuff. Anyway, so an IPA and app, An IPR archive is the file an Apple app comes in, and it's just a zip archive, and it contains a folder, payload folder, an application.app. This has got compiled code and resources. It's got artwork and a metadata with the developer's name and copyright info. It's essentially the same thing as an Android app that we've been unpacking and finding a manifest file and a signing certificate and all the code in there. All right. And in the early days, every app had had access to everything. But then, of course, Apple discovered what everybody else will discover, is that you really don't want to let every app get at the contacts and the camera and stuff. So they defined data classes, just like what you'd see in Android: microphone, Bluetooth, location, contacts, photos, all that stuff. And when you install your app, it will tell you this thing would like to access your contacts, the microphone, and so on. And you can decide whether to allow that or not, which is quite reasonable. And then you can go in your settings and you can turn it on and off for each app. So this app can get to the contacts, but this app can't get to the contacts, and so on. By the way, there was kind of an interesting project. I might add this. There was somebody last week on Twitter that said he set up a firewall so he could watch the network traffic, something that Irvin's also done. And he said, then I ran my iPhone, ran this app, and it set up like my entire contacts list up to their server when I launched this app. And technically it said it was going to access my contacts, but I didn't think that meant that we're going to copy everything about all my contacts and put it up on their server and then do who knows what with it and sell it to other people and God knows what, which is, of course, what they're doing. And that's why it's kind of nice to have a real network inspection device to watch what's going on and off your phone and your apps and other things. And if you do that, you'll find that almost everything is sending a lot of your personal data out that you didn't want it to. Anyway, so iOS 8 added this location information. So you can set your app to never access the location, to always access the location, or to only access it while the app is in use. And it's the same with Android too. So that's a native iPhone. Then there's jailbreaking. Jailbreaking is if you want to do things that break the Apple security model. Now, you can't break the hardware part of the model, but you can break the software part of the model. For example, you can run unauthorized apps that are not signed by Apple. And the most common reason you want to do that is because you want to get pirate copies of things like games, which have been cracked and are no longer signed by Apple. And of course, now you can get malware. So that's the game. And you can also turn on things that are restricted. This is a big deal. I don't know if it's this much of a big deal anymore, but when the iPhone first came out, they actually didn't have enough bandwidth on the back end to handle all the traffic from the app from the iPhones. So they started blocking it in cities and stuff like that. And they really didn't want people using the iPhone as a tether for their laptop to run data through it. So they disallowed that, and so people would get apps, unauthorized apps that would let you tether. Anyway, so of course, if you do this, then now you can run unsigned things, so now you can run malware. And there has been malware for jailbroken iPhones. iKey was the first one that just rickrolled people playing a video, but it just showed that you had been infected, because if you just jailbreak your phone and you don't change the password, they all have the same default password. So they become the same kind of Internet of Things device that keeps getting hacked, where it's just listening on a known port with a default password. And there was another one here that made bots of phones in Dutch users. And then there was Unflod baby Panda in 2014 that hit jailbroken phones and stole Apple IDs and passwords. So an untethered jailbreak is the best, the most strong, where you jailbreak the phone and now you can totally use it like a normal phone. You can turn it off, charge it up, reboot it, and it stays jailbroken. Tethered jailbreak requires a computer every time you restart the phone. Otherwise, you end up in recovery mode because it has to reload the operating system. And then there's semi-tethered, which is, I think, what the one I'm using is, the Cachegrab one, where you can restart the phone without a computer, but if you do, it's no longer jailbroken. So Jailbreakme is the website for the first several jailbreaks that were really famous. The jailbreakers would secretly develop these, not tell Apple, and then they would put it on a website called jailbreakme.com, and for a week or two, everybody could just go to that website and jailbreak their phone. That was easy until Apple found out and patched it, of course. This happened a few times. So they worked by finding vulnerabilities in the browser, often through the PDF reader, which is also how you do a lot of Windows exploits. The PDF format is very complicated, and the PDF readers tend to overlook some implementation of its many complicated features. So you could just go here and jailbreak your device. Then there was the evasion jailbreak, which there was a lockdown service that let you change file permissions. So you could call that function and just change file permissions, and then you elevate yourself to root. All right, and there have been a lot of these, although the jailbreaks are getting tougher. So, all right, so to make a test environment, you jailbreak it. This is one of the few projects that works, the jailbreaking project. It works at least if you can use checkgrain, and some students have got another one to work that I mentioned before. There's a video about there. So you get it after you jailbreak. The first thing you do is put on Cydia. That's what most people want. That is the unauthorized app store where you get all these apps you jailbroke for. And then by default, it will let you control the phone over USB, which is much safer. You can also turn on OpenSSH running over Wi-Fi, but then, of course, anybody in the neighborhood could connect to your phone. So if you don't change the password, it's unsafe. But if you do it through a USB cable, then it's quite safe. You really have to have a physical connection to the phone. The password is Alpine for mobile for the non-root account and root for the root account. Alpine for both of these. That's why if you're going to turn on Wi-Fi, you better change the password. All right, so Cydia is the App Store. Big Boss recommended tools. It gives you the command line tools that you might expect. It's this is a production level Unix device essentially, and so they've removed all the tools that you might want to have on there because it's not intended to develop anything, it's just intended to run apps. So you have to put back in the command line tools, and you have apt, so you can do apt install on your iPhone just like you might on a Debian server. And so there's some special Apple tools just to compile and just to analyze Apple binaries. Remember, Windows are PE files, portable executable files, and Linux makes ELF files, executable link format, but Apple uses Mach-O binaries. That's the format of it. And so, all right, here's some tools that do this. O-tool lets you see the object file, shows you class and method names, libraries, header information. So that's one tool. NM shows the symbol table of a binary file. Lipo is kind of fun. If you have a fat app has multiple copies of compiled code to run on different versions of iOS. And if you, a lipo will let you thin it up so it has only one. I mentioned this, and this happened to several of the Android apps, like I think Home Depot I did for a while. It turned out that Home Depot was a fat Android app, so when students would download it, they'd find different apps there. All right, GDB is the debugger we use in 127 on Linux. It doesn't work very well on iOS. You often use a different one, LLVM, I think, something like that. There's a code signing tool here from Apple, and there's Sorik's code signer. Sorik is the guy that made Cydia, I think. He's the main person that created the Cydia store and maintains it, and almost all the cool tools are from Sorik. There's install D is what's used to install apps. So IPA installer is what is used to install unsigned apps, which is, of course, something that Apple doesn't want you to do, but you can do it on a jailbroken device. All right, once you have jailbroken the device, you can now traverse through the file system, and you'll just see a Unix file system. But you can't read any of the user data. It's all encrypted. There are apps you can put on the phone that will let you view a graphical environment to explore them. And so here's some file system locations that are very much like the OS 10 device I'm using right now, the Mac PC. You got applications, VAR mobile applications here, voicemails, SMS data, photos and videos. And the contacts are stored in a SQLite database address book. And if you do mobile device forensics, you connect it to a phone and it sucks all this stuff down and just delivers it to you, because this is mostly what you want when you do forensics. You don't really care about the operating system. You want the user data. You want the emails, the SMS data, the phone log, and things like that. plist files are a binary format that stores a link configuration files for an app. And plutil is a command line file. Same thing's true of Mac OS X. These plist files are sort of like the equivalent of the Windows registry. They contain useful the parameters that control how a program runs. And there are binary cookies, which you can open with a special Python file, and there are SQLite databases in there. So, all right. I would like to do Cahoots, but Cahoots haven't been working today either. I'm going to give it one more try, but I'm having quite a few problems here. It lets me log into Google, but then it fails to finish the OAuth process and let me in Kahoot. There's been a couple days ago, there's been some kind of bug with Google's API, and I think it's still that way. So apparently we cannot do the Cahoots today. Yeah, free Kahoot points for everyone. Well, yeah, not that. Although in my other two classes, my Monday and Tuesday class, the total number of points is actually going to go down because some more guest lectures appeared, but not this one. However, you could attend the guest lectures, and I should mention that. If you look down here, there's a lot more guest lectures, and they're all security-oriented. Okta, Security Risk and Compliance, a CISO from F5, Information Security Director from Directly, and a cybersecurity at LinkedIn. So 4 talks coming up, and they are worth extra credit, and I highly recommend them. I canceled a few lectures to make room for them because that's real valuable. Get information about different jobs and what they require. So